Bees are definitely one of the most popular animals in the world currently. They are often associated with honey. Perhaps some people don't know how bees make honey, but to put it very simply, they collect pollens and nectars from plants, put it inside a specialized structure inside their nest, which is honeycomb by the way, and then the pollens and nectars will be broken down with enzymes, turning into honey. However, what many people don't realize is, most bees actually don't even produce honey, but they still collect pollens and nectars because that's their primary source of nutrient. And yeah, most bees do eat pollens and nectars, but not all of them. One group of bees are quite famous for their diet. Rather than feeding on nectars, they feed on carrions. However, what's also interesting is the fact that they produce what we call meat honey. I told you about how honeybees make honey, and most people would agree that honey tastes sweet. So now the question is, what would a honey made by a meat-eating bee taste like? Is it umami or is it rancid? But hold on a second, would it even count as honey in the first place? And so, let me bring up the question. What exactly is vulture bee? First of all, it might be obvious from how they look, 6 legs, wings, but yeah, they are insects, which means they are arthropods. Vulture bees are true bees, which means they are classified in the Apidae family, which belongs to the Hymenoptera order. Among the members of this family, they are classified in the Meliponini tribe, commonly known as the stingless bee. These bees typically produce honey. And fun fact, in the tropical area, these bees are the one more commonly farmed for honey, historically at least, while Europeans and North Americans typically farm bees in the genus Apis, aka honeybees. The practice of farming stingless bees is called meliponiculture, while the practice of farming apis or apis is called apiculture. By the way, I'm not gonna delve deeper into this. I'm just mentioning it so you could look it up yourself in case you are interested. Anyway, among the stingless bees, vulture bees are classified in the Trigona genus, but not all Trigona are vulture bees. Only 3 specific species are considered vulture bees, as far as I know at least, which are Trigona crassipes, Trigona hypogea, and Trigona necrophaga. All of them are neotropical bees. Their specimens have been collected from various regions around here, and this would be the time when I usually show you the recent observation data. But, well, let me just show you. See, there is barely any recent observation data, at least not in iNaturalist. I also checked IUCN Redlist and they don't even have a page there, which really makes me wonder, when others made articles or videos about vulture bees, what images did they even put? Because I can barely find any. And so I checked some, and apparently they just put some Trigona images that are not even vulture bees. Now I wonder, perhaps some of the images I use is not even vulture bees. But anyway, they are called vulture bees because they eat carrions. They are also commonly known as carrion bees, by the way. The reason why only these 3 species are considered vulture bees is because, simply, only these 3 exhibit obligate necrophagy. Again, as far as I know at least. Oh, by the way, we already knew about their existence in centuries ago. Trigona crassipes was described back in 1793 as Apis crassipes, but we didn't know they are obligate necrophage back then. Trigona hypogea was described in 1902, but the fact that these bees are obligate necrophage were only known based on an observation published in 1982. For almost 10 years, we thought Trigona hypogea was unique for having this trait, hence that one was the vulture bee. But then, in 1991, a comprehensive paper was published showing the fact that not 1, not 2, but 3 species of bees are obligate necrophage, including the Trigona crassipes that have been described 2 centuries prior, and a newly described species that is Trigona necrophaga. From then on, we coined these 3 as the vulture bees. Oh, by the way, this publication also shows the morphological modification that made them obligate necrophage. So why don't we move on to the morphology section? But before that... In terms of size, I would say they are quite small, especially compared to the popular honeybees. Trigona hypogea is the smallest among them, while Trigona crassipes is the biggest, which is still only around 6.6 mm in total length by the way, so even the biggest among them is quite small. Their coloration is typically dark, but the hair can be quite lighter. In case it's not obvious enough, they don't have stingers, because remember when I talked about the taxonomy? They are stingless bees after all. Oh, by the way, just like many other hymenopterans, they have a significant degree of sexual dimorphism. Workers, aka the generic females, are typically smaller than the males, but they are typically equipped with more tools, because, well, they are the ones who work, while the males mostly just mate with the queen. And while we're at it, one of the noticeable traits that correlates to their necrophagy behavior is this toothed mandible in the workers. This enables them to be aggressive. But not only that, this enables them to rip a chunk of flesh, especially from carrions. That's not the only special thing about them though. Another noticeable trait exists, or perhaps I should say the lack of said noticeable trait. You see, bees typically have a structure called corbicula on the outer side of their hind legs tibia. Corbicula is also called pollen basket because that's what it's used for, to collect pollen from flowers. In the case of vulture bees, they don't have this, hence they couldn't collect pollen, not effectively at least. But of course, they don't need to because they are obligate necrophages. Now to compare the three species. There are some meristic differences among the three species. As you can see in this table, it is quite noticeable in Trigona hypogea, while Trigona crassipes and Trigona necrophaga is around the same size, overlapping with each other. Still, like I said earlier, Trigona crassipes is generally bigger. Besides meristic traits, you could also identify them by looking at the size, shape, and the plumose hair of their head, mesotibia, which is the tibia of their middle legs by the way, and their metatibia, the tibia of their hind legs. Oh, and of course, workers have a different morphology compared to males, so you should also pay attention to that. Besides that, you could also look at male sternites, that's their ventral plates by the way, and you could look at their genitalia. Each species has distinct shapes, sizes, and also hair. You could check out this article for more detail. But besides morphological differences, they also have ecological differences, and you could try to identify the species by noticing some of their behavior. So let's talk about their ecology. It should be obvious by now because I mentioned it multiple times already, but vulture bees are obligate necrophages. If you didn't know, wasps are predators by default, and bees evolved herbivory from their common wasp ancestors. Some bees are indeed facultative necrophage, meaning they will consume carrion opportunistically, but becoming obligate necrophage is on the extreme. Analysis on their gut microbiome showed an abundance of acidophilic bacteria, which means their gut is acidic, just like other carrion eaters, vultures for example. Helps them digest food, and of course, helps in dealing with pathogen. However, acidophilic bacteria are not even the most abundant microbes in their gut. The ancestral corbiculate-associated bacteria are still the most prevalent, which could indicate these bacteria are still crucial for their digestion somehow. In any case, they will gather around a carrion, usually excavates through the soft tissues, then gathering meat from the inside. Just like other bees though, they don't consume it only for themselves. They will store some in their crop, carry it back to their nest, then regurgitate and store it in a special storage spot. There are several differences in this foraging behavior though. For example, Trigona hypogea are not seen chasing away other insects that land on the carrion they are currently foraging. Meanwhile, Trigona necrophaga often chase them away. It is also observed that when Trigona necrophaga of two different colonies stumble upon the same carrion, they will fight each other to death. In any case, the stored meat materials will degrade into what we know as meat honey. In Trigona necrophaga, the stored meat material is consumed first by workers, processed in their stomach. Meanwhile, they also produce special substance from their gland, and then regurgitating those as their quote-unquote meat honey. We also observe some occurrences in which they mix the meat base with sugary plant products, in which you could argue that said sugary plant product is honey, but not the meat base itself. Of course, I understand it's just a name, but in my opinion, if a name could be misleading, we should stay away from it. On another note, some people might wonder, what does the meat paste taste like? Well, I personally wouldn't even try to consume it. It's made out of carrions after all. But hey, humans consume weird stuffs just because we can, So it is what it is. But anyway, these will then be consumed by bees inside the nest, including growing ones. Oh, by the way, Trigona crassipes is known to aggressively defend their nests, while the other two don't. However, in terms of the nest itself, Trigona crassipes and Trigona necrophaga have some similarities. They make nests on tree cavities, constructing a bitumen envelope around it, with a large protruding entrance. They both cover their nest cavities with resins for protection, while Trigona hypogaea don't. Trigona hypogaea nests in a wide array of spots. They could nest in living standing trees, while some nests are found on dead trees laying on the ground. Not only that, they also have the widest distribution, at least as far as we know. This could indicate that Trigona hypogaea is the most basal of them all, because they are still not that specialized. Furthermore, the similarities between Trigona crassipes and Trigona necrophaga might indicate Trigona necrophaga evolved from Trigona crassipes in the Panama. Still, there's still a lot that we don't know about them. There might even be more species of vulture bees that we haven't discovered yet, or at least we didn't notice them to be a separate species. Like I showed earlier, there are barely any observations on them, because their habitat is not exactly easily accessible. Still, dedicated research could definitely accomplish that. And who knows, maybe we simply stumble upon a newly observed behavior stochastically. But for now, let's just learn what is known. And that's all for now. Oh, by the way, I did say Trigona crassipes will defend their nest aggressively, but they are stingless bees so they don't sting. They do have toothed mandible and will bite intensely though, so that's quite something. Anyway, enjoy your day.